All right. I bet you can guess what's coming next. Multiplication, right? If we've done addition and subtraction, we've got to do multiplication. So, are we ready? Let's try 23 times 12. So I want it all in terms of pebbles. So maybe what I should really be saying for my question is,
It's very needs to somehow make this. And then it's just it is. This up here. We have to somehow people should just and multiply by 8. You do add. Oh, the drop rocks thing. What is multiply by 8?
I was thinking, I just went back there, I showed something, so you drag times 12, and then you get 12 groups of that.
Because I can multiply.
So we have 24 dots, and then 26 dots. And then I just go ahead and did the explosion. I got back to, I got 76, I did explosion. So, I just,
so some people seem to be saying that this representation might be a better way to do it. I don't know.
We're times in like 12, right? You mean multiply by 12 means you have 12 groups of whatever you have. Alright, so I have 12 groups, you could run a lot better.
We'll definitely have at least 2 algorithms coming out of this also.
Where do you kind of go? So this is unit, this is tens, this is units, this is tens. Units, we're gonna guys.
No. It should be 20. It should be 23. So, I mean,
yeah, this is the 3. Yeah.
You know, I was trying to do that, but I actually
exactly. Yeah.
Right, if you can figure out sort of different ways of breaking it up into parts. Mm-hmm.
see the 230. Where do we see?
Yeah. No, I think I like it. This is, yeah.
Well, 230
I
is.
like
And then, well, then we need to.
So I think we should use 2 colors for the different types of radiation.
Oh, yeah. No, combine to give black.
Right. So let's do that. I think I like it. The story should be promising.
Then I just had to add. I don't understand how to do it when I have 2 boxes that are different denominations.
You have 10 groups of what you just put here, right?
And then you're going to
So now you have like 6 explosions. Because you've got, so if you have 6 dots and you're doing 10 groups of each of those.
No, I start going back to the original.
Oh, okay.
So there's going to be 30 dots in here. So you're going to get 3 explosions, and you're going to get those 3 appearing here. And then the similar way, you're going to get 20 dots here, and then you're going to get 2 explosions. So visualizing this in terms of explosions.
Oh, this is good. Yeah, this is a classic algorithm too. There's a classic algorithm actually with sticks for multiplication that looks exactly like that, and you count the intersection points.
We don't know that.
So it actually is a classic algorithm. Yeah.
It's going to be a good algorithm.
It's,
Our machine learning is ready to go.
Yeah, but I still think
that's good.
we need the
Do you know lattice multiplication? Do you teach that in your curriculum? Lattice algorithm? In younger grades? Yeah. So they're basically inventing that algorithm over there, or something pretty much equivalent to it.
We like it, but we don't seem to understand any place values associated with it.
That's a problem then, yeah.
before something, I'm like, okay, I can
Now you're
so then I get, 33 explosions. Okay, and now these are going to produce explosions.
They're going to produce
Dots.
dots.
All the energy.
Into maybe some like parallelogram shaped boxes.
If I do that in my head, I'm going to use. Some of my pre-service kids really like the method, even if they've never seen it before.
Some kids really like it. My son loves it. It's his favorite. Yeah.
And he's like, oh, well, what kind of math do you do? And I said, well, right now I'm kind of interested in lattices. He says, that's what we learned today too.
Cool. How's it going? Yeah. So can you tell me what you got? Oh, you have two ways. What do you got going here?
Well, the way I started out with 23 with 2 in here and 3 in here, and I just thought multiplication is that's how many groups that I have. So I have 12 groups of this picture here. I didn't write it all out. I know I had 24 dots in here, 36 dots in here, and then I did the explosions. And he did pretty similar, but then he broke into 2 and 10, more compatible numbers, like smaller numbers, and then added them at the end. You got the same. You were doing something too.
Well, I was just approaching it from an area model standpoint, thinking about all the partial.
I think it might be a little tricky to figure out how to turn this into an area model.
That's what I said. With the explosions, I was like, I don't know where to go with that, with the explosion piece of it.
Yeah.
So, but
I think you can do sort of the area model, but a little bit more like, do you do lattice multiplication?
We do.
So your area model can sort of relate to the lattice also, and then the lattice can make sense with dots. These guys will show you their idea, which involves, I think, lasers and I don't know what else.
I don't know if you have a machine. I mean, I guess you do that. I don't know what would make you like what.
Well, so you're doing this algorithm essentially.
Right, I'm doing this one.
Yeah. Yeah, that's great.
So, I mean,
And then the question is, can you come up with an algorithm that kind of uses this structure instead?
yeah.
Right. This is a great one. No doubt, it's one of the ones we'll talk about for sure in a couple minutes here. But to keep thinking about, is there some way you can use this representation to make something that doesn't require drawing quite as many dots? Yeah. Oh yeah, like what you've got. Exactly. Yeah.
But how do you argue that this, when you do that one and that one, you guys move there?
20 times 10 is 200.
Yeah. I mean, but you're not.
You can argue it in some kind of place value-y way, like moving over one space is a pebble in larger, right? And so you can make some kind of argument like that. I don't know.
In that number course, after your initial multiplication.
Yeah. Right.
Because you're still multiplying by 12. So
It can be multiplying by 10 and by 2, and then adding.
that's what we did here.
Right.
It's still the same. You should
Yeah.
end up with the same thing as
But maybe there's another way of thinking of the multiplication by 10. Like imagine if you were required to actually draw every dot, or actually physically go get a pebble for every one, so it was a real pain. So you wanted to do this process using the fewest possible pebbles for all your steps, so you don't have to go fetch them.
That's what yours is.
Then something more like this.
Grouping as you go.
Yeah, but how do you do it? Not with regrouping, but just like try to boil it down. I mean, you have two great algorithms here, but I'm looking for something that more directly captures the place value through the boxes and not through piling 20 pebbles all into one box and 30 pebbles all into one box. Because it's really like if you were doing it in normal math, it would be a 3 in the tens place. It wouldn't be a 30 in the ones place.
Right.
Right? So what's a pebbles metaphor that does that same thing? Of instead of putting 30 pebbles in the ones place, puts 3 pebbles in the tens place.
To me, this is more traditional algorithm. Like for this
Yeah.
one, I was doing my ones times my ones, my ones times my tens. You see, then I have my tens times my ones.
Yeah.
This is my tens times
So
my tens.
then you need a pebble explanation for the shift over of one box, right? That's what you're hunting for.
And then in this
Right, and then the lattice method, absolutely.
Separate it like this is times my ones and this is times my tens. So I left the ones
Right.
blank there, and then I would have to add those two together.
Yeah.
And but I'm not exactly sure. I'm sure somebody else.
So maybe somebody will have a better pebble. Well, I mean, the way is to do it the way you're doing it. The question is, how do you explain that in terms of pebbles in some way that makes sense, right?
Yes.
Yeah.
Well, if you multiply a 1 times
Oh, now I get it. Yeah, finally, it makes sense.
I think I built the machine correctly this way, but
I think it'd be nice if you this is really 30 times 20. This is be 21 times 23 to me.
I put for some reason the units here.
Right, but it should. I mean, the machines go right to left, so it should still go right to left of increasing. So the highest place value should be the farthest left.
All right, so you think I did 23
Times 21. That's how I would describe that. Yeah.
And then it makes you lower.
I definitely should. It's definitely not 23 times 4.
Yeah, that would get tricky.
Because this actually illustrates what we were doing.
It does.
Have you played on National Library Virtual?
Oh yeah, sure.
So I was just showing.
Right, this is the
kind of
base
that
10 blocks,
concept.
same thing.
Cool blow up, but
Right. Yeah, when you click on the 10, and it should into 10 ones, and you should circle 10 ones, and they should go.
back in.
Yeah.
Yeah.